In this video, we're going to look at the number of games that occur in all of the World Series since 1923. We can start by stipulating that in a World Series, the two teams should be pretty equally matched. So we can assume that the probability of one team winning is 50% and the probability of the other team winning is 50%. We, of course, are discounting the home field advantage, which is usually about 4% or so. Let's do some simple probability to figure out what are the chances that a World Series should only go 4 games. Well, for that to happen, we would take the chance of winning a game, 0.5, and we would multiply that by itself 3 additional times, once for each game. So for a 4-game sweep, that should happen 1/2 by 1/2 by 1/2 by 1/2% of the time. But we have to multiply that by 2 because we have one team sweeping, or we could have the other team sweeping. So if we do that, and we have written out the formula here, if we do that, then we would figure that roughly 1 chance in 8 would stipulate the probability that a World Series sweep would be seen. Now, how about the probability of World Series going 5 games? Well, here, what we would do is to multiply 0.5 by 0.5 by 0.5 by 0.5. Then we are going to have to multiply by 4. And the reason for that is that there are 5 different ways to order 4 wins and 1 loss. So you could lose the first game, lose the second, lose the third, lose the fourth, or lose the fifth. But losing the 5th game would not qualify for our analysis here, because that means you would have won the first 4 games and you would have swept. So there are really only 4 possibilities for having a 5-game win. You have to lose 1 game, but it can't be the last game. So that's why we multiply by 4. And then again, I multiply by 2 to accommodate the fact that there are 2 teams. So doing that, we find that the probability of getting a 5-game series should be 1/4. Then we go to the 6 games. And here we again are going to need to modify our equation by the number of different possibilities. So it turns out that there are 15 ways to order 4 wins and 2 losses. But some of those are going to entail the loss coming at the end, in which case you would have swept a series or have won the series in 5 games. So there are only 10 possibilities where the wins and losses actually would allow the series to have gone for 6 games. So we're going to multiply the chance of winning each game, 0.5, times the 6 games. So 0.5 times 0.5. And what I've done here is simply to raise that to the 6th power. It's the same thing. And then I multiply by 10 because those are the number of possible combinations. And then again, I multiply by 2. And if I do that, I find that the chance of a World Series going 6 games should be about 31.25%. Now, we could also figure out that information inductively. So we know that the probability of a World Series going 6 or 7 games has to be the remainder of the probability from a series only going 4 games or 5 games. So if I take 100% and I subtract the probability of going 4 games and the probability of going 5 games, then the probability of either a 6 or 7 game series would be 62.5%. Now, if a World Series gets to 3 and 2, then there's a 50% chance it's going to go 6 games, and there's a 50% chance it's going to go 7 games. So the probability of a World Series ending in 6 games should be equal to the probability of a World Series going the full 7 games. So if we take this probability 6 or 7 and divide it by 2, then we get 31.25%, which is what we calculated directly up above. So with this command, what I've done is to upload a CSV file that I created simply by scraping a table off of the Wikipedia page. And you can see that I make my any strings not factors. And I've loaded the data frame you can see up here in the global environment window. So let's take a look at the data frame. So I've got year, I've got the winner, I've got the length of the series indicated as a character, and I've got the loser. If we take a look at the head, I've got this odd information here after the names of the teams, but really what I'm interested in is the length of the series, and here are the different years. So the length of the series I had to indicate as a 4 underline 2. So at any rate, what I'm really interested in is the distribution of the different lengths of World Series over the course of time. I started in 1923 because it's only since then that we have had a standard best of 7 World Series. In 1922, there was a best of 7, but there was a tie. And so I didn't know how to accommodate that. And prior to 1922, World Series went. Prior to 1922, World Series went different numbers of games. For instance, the 1919 Black Sox series was a best of 9. So I'm restricting my analysis, therefore, to just World Series where there was at most 7 games played, and the winner had to win 4 games. What I'll do now is just to use the table command, and we will look at the distribution of the lengths of series. So I'm going to put this information in our object I'm calling WS tab, and we'll take a look at tab. And here we can see over the past years, there have been 18 World Series that were sweeps. There have been 19 that went 4-1. There were 20 that were 4-2, and there were 35 that went the maximum number of 7 games. I will now test the observed values against the expected values, and I'm going to do that by using the chi-square test. So I'm simply calling that function with this call here, chi-square.test, and I give the table that I'm going to be analyzing, WS tab, and then I'm stipulating the probabilities. So this information comes from above, where the chance of a sweep should be 1 chance in 8, the chance of a 5-game series should be 1/4, chance of a 6-game series should be 31.25, and the chance for a 7-game series should be 31.25. So the chi-square test is going to compare the observed proportions against the predicted ones. So I'll run that line of code, and I'm saving the results into an object I'm calling WS chi. And we'll take a look at WS chi, and you can see that the p-value here is less than 0.05, which means that we have a divergence from the expectation. In other words, the distribution of the lengths of World Series do not conform to our expectations. Anytime we do an analysis in R, we can usually find information on that analysis using the attributes command. So as long as we save our analysis to a object, WS chi in this case, I can ask what information is available, and you can see down below that I have various and sundry statistics that I can call. What I'm going to do here is to use a couple of them. One is the expected number, so I'm going to call that expect. So I'm asking for the expectations. And I'm also going to have the observed values that are down here, and I'm going to call those and assign those to OBS. So I'll run that as well. And what I'll do is to simply combine those two vectors into a data frame, and we'll take a look at the data frame. And here is what we find. We observed over the course of these years 18 World Series sweeps. We only expected 12. We found 19 4-1 series, and we expected about 23. So that's a pretty close number there. Here we see only 26 game series when we expected 29. And for the number of series that went full 7 games, that's happened 35 times, and we expect that to happen about 29. So not a great divergence there. So the two most unexpected differences are an over-representation of sweeps and an under-representation of 6-game series. Now, the explanation for these patterns is, of course, manyfold, but one idea is that we know that once a team is down 3 games to none, that all hope is lost, it would seem, and that, in fact, never in a World Series has a team ever come back from being down 3-0. In fact, in all of playoff baseball, it's only happened the single time when the Boston Red Sox came back against the New York Yankees in 2004. So there may be some psychological impact here that once you reach 3-0, the chances of your opponents winning the next game may be significantly diminished. And then in this case where you are up 3-2 and fail to win the 6th game, so the series therefore is forced to a 7th and deciding game, it may be that the team that's down 3-2 is literally playing for their World Series lives, and that the team that is up 3-2 may subconsciously at least realize that they have 2 chances to win 1 game, and so they might let up a bit in the 6th game. But at any rate, we see that there are fewer 6-game series than we would expect based on our simple probability estimations.